Hi. Exam 3 review, right? So much enthusiasm on both ends. Just for the record, you could have picked to skip it too, but. So, exam 3 is on chapter 4, and we're going to skip 4.8 on the test. The homework for 4.8 is posted, and you're supposed to do the homework. Now, the reason is that it's not on a test is because of the extensive amount of calculations you have to do, and it becomes really annoying, and you don't have the access to the graphing calculator, so you can program it to grind quickly through those things. So, no 4.8. Now, what are the important things that you guys need to worry about? Number one is going to be min-max. This is a straight-up calculation from 4.1. Number two, you need to worry about mean value theorem. I'll put in so get x equals c. So you have to find that c where the average equals the instantaneous. You will see that in notes in the video if you go back and review. Number three, first derivative test, also known as FDT. So a problem on that. Separate problem, different function, no connection to this one. Second derivative test, SDT. Number 5, graphing. Now, all parts given, just graph. So it's not going to be a problem where you have to sit there for 40 minutes and crank through all of those calculations and then mess up on the first derivative and the whole thing goes to hell, right? I'm going to provide you with asymptotes, intercepts, increase, decrease, concavity. I'm giving you everything. You need to use that information and just draw the line. Because, as you can see, individual pieces of that calculation you're going to have as separate problems. So there's no reason to double up on all of that work. I mean, I could technically make a test, give you one of these graphing problems from scratch, and 2 word problems and call it a day, right? Because it would literally take you an hour and 20 minutes to do those 3 things. Instead, you are going to have 10 questions, but this problem, right, on graphing will just be you graph. The next one is a linear approximation, which is the tangent line. And I can't care less if you're going to use the L formula or you're going to use the tangent line. I don't care, right? So number 6 is linearization. And in parentheses, I'm going to put tangent line. It's the same concept. Whichever one you use, you will have to get the same answer. 7 is differential. And this could be either a regular problem or a word problem. So I'll just put maybe a word problem. Number 8 is going to be min-max, also known as optimization. Word problem. Number 9, integrals. And number 10 3.11 related rates, word problem. Maybe if I need to fill in for the problem 10. Like if I go and give you exactly what you see here, then related rates is in. So for integrals, I have part A, part B, part C, let's say, and then the rest of the stuff. If there is something that is very easy, related rates, optimization problems, those are insanely important for your future employment and ability to operate, obviously. So I am concerned with those. Also, I am concerned with you being able to differentiate, right, between the two problems, not just by looking at the words and wording of the problem, but also, the way to do it. So 3.11 might make the appearance again. 3.11 is definitely on your final, so it doesn't have to, appear here, but it could be used as a filler, right? Since we don't have 4.8. So you still have technically 9 sections to worry about, but you already had 3.11, and I wasn't particularly happy with the way the 3.11 went last time, which is why I am thinking about including a problem from 3.11. We'll see the way it goes. So that's the list for exam 3. You know that the stakes are high at 16% this time, right? And you can make up a lot for your past performance by doing well on this particular exam. So you have 6 days. I hope that tonight you are going to do the sample exam in my MATLAB to see where your issues are, and then fix those issues by next Monday. Stop by my office hours, obviously, go to tutoring, use essential oils, whatever helps for you guys to figure that out. Do I need to show you one more time where those sample exams are?
They're under quizzes and tests.
Excellent. When you go into my MATLAB, where you do your homework, you will switch, when you click on assignments, you will switch to quizzes and tests and scroll down to sample exams. You are looking for chapter 4 post-test. Let me write that in blood. Sample exam, my MATLAB, chapter 4 post-test. It should take you about 2.5 to 3 hours to completing the test because it has over 20 questions. If it takes you 1 hour and 20, right, for 10 questions, then double it for 20. So if you do that tonight and just get your score and go to bed, starting tomorrow, you will know exactly what you need to work on the most to improve your knowledge and prep. Good. I'm out. Now, what are your questions? Do you have any math questions, anything? Mel, you had something you said?
Yeah. When you have a parabola,
Okay.
you take the second derivative of it, you're not going to get really a value for x, right? You're just going to get...
You are going to get a number.
Yeah.
And that number is already smaller or bigger than 0. So the entire function will just be concave up or concave down.
Right.
So here is the example. Now, if you have 3x squared plus, let's say, 9, right? That's your function, f of x. And you take the second derivative, well, take the first one first, which is going to be 6x, and then the second derivative will be 6. See, second derivative 6 is bigger than 0, which says that the whole function, is concave up. Well, you know that the graph for this puppy looks like that. So the whole function is concave up, right? So you are going to get in that. Now, if it's a negative, it will be opening down and the whole function will be second derivative would be negative, so the whole thing. So yes, if you end up with either first or second derivative, if you end up only having a number, then the whole function follows what that number is in comparison to 0, smaller or bigger. What do you have?
On the quiz, it asked a bunch of linear approximation, like natural log of 0.92 or like 0.96, and it said you can choose A yourself. So I did 1, but then I'd end up with like 0.96. Like,
okay. But you chose 1.
Yeah, for this one, and then I'd end up with 0.96.
What do you mean you end up with? You are trying to approximate. You are trying to approximate 0.96 or 0.92?
Well, like there was this one and then there was this one. I actually did this one out on this paper. That's what I did.
Okay.
And then I would end up with natural log 0.96 equaling 0.96.
Okay. Did you try that? Didn't work out?
No, it was like negative 0.
Negative 0. Okay, good. What did you have? You had something similar?
Same problem as Mel, but like what if it was cubed?
Oh, in that case, you're not going to get the constant.
Yeah.
On a cube, you're going to get 7x, and then you have to do the less than 0, more than 0, and concave up on this part, concave up, right? So in that case, you will have partitioning. So only for the squared ones on a second derivative, you are going to have a number, and then the whole function behaves that way. But for the cube, you are always going to get or 4th degree or 5th. On a second derivative, they will. Let's do, so you want a 9.2 or 9.6?
I don't care. Like they were both on the quiz.
So let's do 9.6 since. And we're going to do this in 2 different ways. We're going to do it with linearization, and we are also going to do it using differentials. So we'll do the same problem 2 different ways. So let's go and work with the linearization. Now, linearization is either you know the L formula or you use the tangent line. L formula is tangent line written in 1 line, so same thing. All right, so where do I start? Well, I start by picking A to be 1. And then know that ln of 1 is equal to 0. That's why we pick the value of 1. What are the good values to pick when you have ln? The good values are 1, e squared, e cubed, e to the 4th. Also good value, 1 over e, 1 over e squared, 1 over e cubed. So you want you just want powers of e. And when the power is 0, it actually works out to be 1, right? So when you have an ln problem, you always want to pick e to the power, and then you will just use your calculator to figure out which e is the closest to, right, that 0.96. Now in this case, e to the 0, which is 1, so we're just going to leave it there. Now, the Lx formula was f of a plus f prime of a x minus a. Now a equals 1 for this formula. So L of x is f of 1 plus f prime of 1 times x minus 1. Now my function f of x is ln x, and the derivative of ln x is 1 over x. So I just need to plug all of that in here. So L of x is f of 1, which is ln of 1, plus the derivative of 1, which is 1 over 1, and then x minus 1. So L of x is equal to ln of 1 is 0, plus 1 times x minus 1. So what I got here is that my linearization, or the tangent line, is x minus 1. That's what I have. So now, to approximate ln of 0.96, I just need to go 0.96 minus 1, which is negative 0.04. So once you figure out your linearization, you take the number that you don't want to compute in original function and compute it in this function. That's why you found this, right? Because computing here is much easier than computing in ln. So once you find the tangent line, the value that the problem wanted you to compute, you compute here. So, they're supposed to say squiggly equal over here. Squiggly equal because it's approximation. All right, same problem. Same problem. Use differentials. So I want to approximate ln of 0.96. We are using the fact that your x is going to go from 0.96 to 1. That is making your delta x 1 minus 0.96, which is 0.04. Delta x is a difference in change of x, right? It is a change of x as x goes from 9.96 to 1. The differential is that dy is equal to f prime of x delta x. So we have our f prime, which is 1 over x delta x, and dy is equal to 1 over 1 times 0.04, and that's going to give us 0.04. So now, to calculate ln of 0.96, we are going to take, approximated by, ln of 1, and we are going to subtract the change. Because we are saying that the problem we are looking for, which is 0.96, is the same as taking the ln of 1 and then subtracting the change to bring it down. ln of 1 is 0 minus 0.04 is negative 0.04. We got the same value as before. Now, if you want to check all of these, right, you can punch ln of 0.96 in your abacus and figure out. So ln of 0.96 is going to be I have no clue how I pushed 5 at the same time, but somehow I managed that. Ln of 0.96 is approximated by negative 0.040822. So I am very happy with my answer because, as you can see, it matches at least first 2 decimal points. Happy?
Yeah, I think
Good.
just with like the one, I think I just never
Plugged in.
Yeah, I think it just.
You never computed the value.
Yeah, otherwise I was.
Okay. As long as you know the whole process, and then at the end just compute the value. Would be fine. Any other questions? Yes, Mel.
Wait, so why did you do 1 minus 0.04? Like, I know it's supposed to be negative, but why did you subtract it?
Are you talking about this line?
Yeah.
So remember that we can't calculate this in our heads, but we can calculate this one, which is bigger than this, right? Because that number is bigger than this number, and ln is increasing function. So instead of computing the number that I cannot compute, I'm going to compute the number that I can compute and subtract the difference which I got here, because I need to go smaller, right? Because this number is bigger than the one I need. So I'm subtracting the difference. In some cases, you're going to add the difference. Can I use the same method to compute the ln of 1.04? Yeah, I can, right? Except at the end, it's just going to be a plus over here, right? It's going to be a plus there. And that's it.
And L'Hopital's is definitely going to be on the exam too.
Did I miss that on the list?
Yeah.
Yeah.
It was on the quiz.
Holy nightmare! Did I miss L'Hopital? Terrible. This is what it means when you have to pay attention. So I'm swapping now, putting that there. Without L'Hopital, guys, half of your Calc 2 is gone. Chapters 10 and 11, just kiss them goodbye. All right? Important. Important as hell. Hey. There we go. L'Hopital rule. A, B, C. Right? So there's going to be a vanilla problem that you should be able to do in literally 3 seconds. Right? It's already 0 over 0 or infinity over infinity. You just differentiate. So 5 seconds and that's it. And then the other two, one of them will probably be 0 times infinity, because we must have that. And probably one of the exponential ones, because you have 3 different flavors. So pretty much that will be on L'Hopital. And L'Hopital's rule will be used, well, there's also another section in chapter 8 where you're going to use L'Hopital in Calc 2. So chapters 8, 10, and 11 would use L'Hopital rule in Calc 2. So it's insanely important. Good catch.
It's actually about L'Hopital's rule, like one of the questions on the quiz.
Cool.
It was it's like the limit as x reaches 1, and then it's a fraction, it's ln x over 23x minus x squared minus 22. Like, I know how to get to the problem, it's just using
23 minus x squared minus 22, like this?
Yeah, it was like that.
Really?
Because another one is like 6x minus x squared minus 5. Like, I know how to get the answer, it's just with L'Hopital's rule.
Okay. So what do I have? When I plug in 1, ln of 1 is 0. And when I plug in 1, 1 squared is 1. So 23 minus 1 is 22. Minus 22, we have 0 over 0. So because we have 0 over 0, we can immediately hit this with L'Hopital's rule. And now the derivative of ln x is 1 over x, and the derivative on the bottom is negative 2x. Because derivative of 23 is 0, derivative of 22 is 0. Those are just constant numbers. The only derivative we worry about is negative x squared, which is negative 2x. So now we use algebra to clean this up, and this becomes 1 over negative 2x squared. So the whole limit is negative 1/2. When you plug in 1, right, for x squared.
So what would you have, you know how like sometimes you have to keep doing L'Hopital's rule?
Mm-hmm.
Would that be,
When you have 0 over 0. So if you, oh, I wrote a 0 here, it's supposed to be 1. Hold on. Come on, eraser. So look, you're supposed to check using this. So when I check now, 1 divided by 1 is 1,
yeah.
and divided by negative 2. I could have solved it there, but I fixed the algebra.
because
So you see, it's not 0 over 0, right?
okay.
So how do you know if you need to go again? It's either 0 over 0 or infinity over infinity.
Okay.
As long as you have that, you keep going L'Hopital, L'Hopital, L'Hopital. If you see that if you see that the problem is getting worse every time you do the L'Hopital, that means you made a wrong choice.
Yeah.
So you gotta flip them and then.
Okay.
Any other questions, concerns, problems?
I had one more about.
Go ahead. No one is asking anything else.
Okay. It was on It was a antiderivative. It's just find the antiderivatives of f of y equals -3 over y to the 4th.
-3 over y to the 4th, and then dy. So we kick -3 outside, and we have y to the -4 dy. You can have any values. So that's -3, and now we have to do the +1 formula. So that's going to be y to the -4 plus 1 over -4 plus 1 plus c. That's -3 times y to the -3 over -3. You see these guys cancel. And your answer is 1 over y cubed plus c.
Oh yeah, because it was an exponent when you do that thing, the x to the n plus
1, yes. Because it was of the form x to the n.
Yeah.
Now, we don't care if this n is integer for a polynomial or negative integer for this situation of a rational, or a fraction for your roots, right? All of them fall into the same rule. Anything else? We still have 7 minutes, and we can stay longer too.
Can you do an example on like a first derivative test?
Yeah, which one?
I haven't taken the quiz yet. But hold on, let me find it. Give me a second.
I'm not in a rush. If you guys want to go, go. It's okay.
Actually, never mind.
So first derivative test, you take the first derivative, you set it equal to 0 to find your critical points, which would partition. You also need to include vertical asymptotes to partition as well. So partitioning is done with both of those. And then you might end up with multiple partitions. And you pick a test point, you stuff that into first derivative. You got, if it's smaller than 1 at the end, so smaller than 0, if it's negative, function is decreasing. If it's positive, function is increasing.
Oh, that's called like the concavity thing.
Concavity is the second derivative.
Yeah. Okay.
So calculations are the same, except you go off of the second derivative.
Yeah.
Yes?
So for 4.5 optimization, with the final problem, you kept like going and going and going, like building on that problem. Is the test going to be like that, or just like one?
No, it's going to be one problem, one of those or something else. It's not going to be A, B, C, D with 15 optimization problems. What I did there is just to show you that the mechanics of solving the problems are identical. The only thing you have to worry about is the perimeter formula, right? Because the fence, right? How many x's, how many y's, and that good stuff.
Wait, so after the test, I remember you talking about it on Monday.
Yeah, I was thinking we can go home, but then in order for us to have a review for the final, I will have to teach 5.3 after the test, which is short, so we might still end up going early. 5.3 should not take longer than, 20 minutes or so. So that will just add the time to review for the final. So,
And the project you posted on Canvas?
project is in the folder of project. You have 3 problems. One of them is for you to make a box of the maximum volume, so you know what it is, which kind of problem it is. One is with the airline tickets to find the best price, so you know what problem it is. And there is another problem which I can't remember. Antibiotics. Okay. So 3 problems. Solving them with math for that should not take long time. Oh, so we're done with the review, right?